Hello everyone, welcome to the Unacademy YouTube channel. Let's crack it. GATE and ESE Mechanical Engineering. This is your Sathyamoorthy sir. In this video, what we are going to discuss Linear Algebra Previous Year Questions Part 4. Already in the previous videos, we have started the Linear Algebra Previous Year Questions for the Mechanical Engineering students. So today also, it's a continuation of the previous year question. I hope you all are preparing well for the GATE 2023, right? So now completely previous year questions, solutions, discussions we are going to have for the next 1 hour, right? Today Eigenvalues and Eigenvectors previous year questions will be discussed from its basics. First question. For the matrix 4 1 1 4, the eigenvalues are, what are all the eigenvalues for this matrix? There are two methods we can apply. Method 1 and formula based method. Method 1, formula based method. Is it okay now? I will show you what are the two methods we are going to discuss. Here, method 1, I will explain the things one by one. Method 1 discussion we are going to have today. Method 1, it's a formula method, characteristic equation, lambda square minus s1 lambda plus s2, it's equal to 0. So what will be the value of s1 and s2? So this is what now we need to discuss. S1, here, sum of the main diagonal elements. S1 is equal to sum of the main diagonal element, that is 4 plus 4, it's equal to 8. 4 plus 4, it's equal to 8. Okay, next. S2, it's a determinant of the given matrix. 4 1 1 4. And if you consider it, what will be the value? 16 minus 1, it's equal to 15. Now substitute the values into the equation. Lambda square minus 8 lambda plus 15. So here the characteristic equation, while multiplying the two numbers, it must be equal to 15. Addition of the same two number, it's minus 8. What are the two numbers? Lambda minus 3 into here lambda minus 5. Minus 3 into minus 5 is equal to 15. Minus 3 plus minus 5 is equal to minus 8. Therefore, lambda is equal to 3, 8. Yes, 3 and 8 are there. And one more. It's a method 1. Method 1. Method 2, property method. Method 2, property based. Property based. So what is meant by property based? So how to do the property based things? And coming to the property based method, sum of the main diagonal elements equal to sum of the eigenvalues. It's equal to sum of the main diagonal elements. Yes, good morning Rahul. Main diagonal elements. It's a GATE 2003 question. Sum of the eigenvalues we require. So what will be the lambda 1 plus lambda 2? It's equal to sum of the main diagonal element 4 plus 4, it's equal to 8. So only option C gives the sum of the two elements is equal to 8. Other thing, it's 0, here minus 8 plus 5. So plus 8, it's equal to option C, right? Okay, next. Sum of the eigenvalues of the below given matrix, given below is, what will be the sum of the eigenvalues? So as per the previous one, look at this, and coming to this point, sum of the main and element equal to sum of the eigenvalues. So if you require the sum of the eigenvalues, lambda 1 plus lambda 2, it's a 3 cross 3 matrix, so we will get 3, completely 3. Lambda 1 plus lambda 2 plus lambda 3 is equal to main diagonal element, sum of the, that is trace of the matrix, 1 plus 5 plus 1, it's equal to 7. It's a mechanical engineering GATE 2004 question. It's option B, right? Very good. Next one. Eigenvalues of the matrix. What will be the eigenvalues of the matrix? S is equal to 3, 2, 2, 3 or 5, 1, 1. What are the eigenvalues of the matrix? S square is equal to, that is matrix S into S. There are 4 options are there. So there are 2 properties we can check. Now look at this. First, if eigenvalue of S is equal to lambda 1 and lambda 2 means S square eigenvalues is equal to lambda 1 square and lambda 2 square. So here 5 and 1, therefore S square belongs to 5 square and 1 square. 5 square is equal to 25, 1 and 25 are the right solution. Yes, very good, Nikhil, Rane and Rahul. Alright, next. If a square matrix A, it's a GATE 2007 question. It's a GATE 2007 question. If a square matrix A is real and symmetric, then the eigenvalues are what? It's a property always real. Always real is the right solution. It's option A. Next one. Yes. Here it's a GATE Mechanical Engineering 2008 question. Matrix, they are giving 1, 2, 4, 3, 0, 6, 1, 1, P. One of the eigenvalue, it's equal to, that is one of the eigenvalue, let us take lambda 1 is equal to 3. Sum of the other 2 eigenvalues, what will be the sum of the other 2 eigenvalues? And lambda 2 plus lambda 3. What will be the lambda 2 plus lambda 3 value? Can you give the answers in the chat box? What will be the option? What will be option for this? Nice. C. Yeah, exactly. Because lambda 1, sum of the eigenvalues, lambda 1 plus lambda 2 plus lambda 3 is equal to sum of the main element, 1 plus 0 plus P. Therefore, lambda 2 plus lambda 3 is equal to P plus 1 minus 3. Right? So, it's equal to P minus 2. P minus 2, it's option C. It's 2008 question. Students, I am handling the complete engineering mathematics for the GATE 2023 aspirants in the Unacademy platform plus platform. So already I have completed 2 chapters, Linear Algebra and Calculus, and day after tomorrow I am going to start. Coming Monday onwards I am going to start the new chapter, Differential Equation chapter. So try to attend the classes so you can get complete clarification on the engineering mathematics, right? Next. Now, Eigenvectors of the matrix, that matrix is 1, 2, 0, 2 are written in the form of 1a and 1b. What is the value of a plus b? What is the value of a plus b? So this is what now we need to calculate. What will be the solution? Yes, for XE also it's common. Engineering mathematics is common for all department. Okay, for XE also I am handling it, Nikhil. So I will make you comfortable in the engineering mathematics. So in the Unacademy learning app, search my name Sathyamoorthy V and follow my profile. There you can get the ongoing course, complete course on engineering mathematics for the GATE 2023 aspirants. Okay. Okay, fine. In the plus course, I am discussing all department previous year questions. Not only mechanical, EC, EEE, CSE, chemical, all department previous year questions I am discussing. Okay, here can you give the solution? Eigenvectors, they are giving eigenvectors. There are two formulas we are aware of it. What are the formulas? Ax it's equal to lambda x. Here x eigenvector. First we require the eigenvalues for the given matrix, right? How to identify the eigenvalues? Yes, it's a triangular matrix, therefore eigenvalues are lambda 1 is equal to 1, lambda 2 is equal to 2. It is not necessary to identify. For the triangular matrix, always main diagonal elements are eigenvalues. Now, matrix, let x1, this will be the capital X1, this will be the capital X2. Now the first one, matrix into capital X1, it's equal to lambda 1 capital X1. Now 1, 2, 0, 2, then 1a, it's equal to 1 into x1a. Now simplify the equation. First row into first column. 1 plus 2a, it's equal to 1 plus 2a is equal to 1. From this equation, a is equal to 0. Okay, fine. Next, second one. A into x2, it's equal to lambda 2 into x2. Lambda 2 into x2. What will be the matrix? It's 1, 2, 0, 2. It's equal to lambda 2, 2 into 1b. Here we need to multiply the b also, right? It is 1 and b. Then it's equal to 1, here it's a b, it's equal to 2 into 1b. First row into first column, 1 plus 2b, it's equal to 2. What will be the b? B is equal to 1 divided by 2. A is equal to 0, b is equal to 1 divided by 2. And what will be the answer? It's a plus b. A plus b is equal to 0 plus 1 divided by 2. It's equal to 1 divided by 2. And solution. What will be the solution? It's option B. Next one. One of the eigenvector of the matrix. What will be the one of the eigenvector of the matrix? You try this problem. It's a GATE 2010 question. It's a GATE 2010 question. One of the eigenvector. What will be the one of the eigenvector here? We will check it. First, eigenvalues. Lambda square, actual procedure. S minus S1 lambda plus S2, it's equal to 0. Plus S2, it's equal to 0. Yes or no? Okay. Now, coming to this point. Lambda square, S1, sum of the main element, minus 5 lambda 1. Determinant 6 minus 2, it's a plus 4 is equal to 0. Now, product is equal to minus 1. And addition is equal to minus 5. That is minus 1 and minus 4. Lambda is equal to 1, 4. First, eigen vector formula. So, we need to identify the eigenvector. Now, Ax is equal to A minus lambda. So, we can write directly A minus lambda. A minus lambda I into x. A minus lambda I into x, it's equal to 0. Now substitute in this question. Now matrix A 2, 2, 1, 3 minus lambda. First 1 into identity matrix 1, 0, 0, 1. 1, 0, 0, 1 into values x1, x2, it's equal to 0. Now multiply the value inside. While multiplying, 1, 2 minus 1, 1, 2, right? First one, 1, 2, and 1, 2. Now we are getting the equation, two equations, same, identical equations, right? And if you consider the two equations are identical equations, what about the identical equations? So coming to this point, we are getting x1 plus 2x2 is equal to 0. Now x1 is equal to minus 2x1. Now we need to consider x1 is equal to 1. Choose when x1 is equal to 1, x2 is equal to minus 2. Or if you choose x1 is equal to minus 1, sorry, x2 is equal to 1, x1 is equal to minus 2. Or if you choose x2 is equal to minus 1, x1 is equal to 2. If you consider now x1, x2 value, what will be the x1, x1, it's equal to either 1 minus 2, sorry, it's different, right? Excuse me. Yes, here it's 2 minus 1 or minus 2 plus 1. And if you compare these two values, yes, it's available. A, option A. Is it okay? So first lambda is equal to 1 itself, we are getting one of the eigenvalue is equal to 2 minus 1. Is it okay? It's option A. Option A is the right solution for this question. One of the eigenvector. So what is eigenvector? How to identify the eigenvector? What are the shortcuts for the eigenvector? Everything I have discussed in the plus class itself. There you can watch. Okay. Next one. Eigenvalues of the real symmetric matrix always what? It's a GATE 2011 question. Always real. It's a repeated question in all departments. Eigenvalues of the real symmetric matrix always real numbers. That is the concept. Okay. Next. Eigenvalues of the symmetric matrix are what? Eigenvalues of the symmetric matrix always all are either complex with non-zero positive imaginary part, complex with non-zero negative imaginary part, purely imaginary or real. What will be the solution? It's always real. Okay, next. One more thing. One of the eigenvector, as like in the previous question. So already we have discussed one question, right? In last minute. The same kind of question. One of the eigenvector of the matrix. So how to identify the one of the eigenvector for the given matrix? Is it possible to identify it directly? Guys, are you there? You try this, then parallelly I will explain the solution for this question. And coming to the Eigenvector. So first we require the eigenvalues. Lambda square minus s1 lambda plus s2 is equal to 0. We require the s1 value. S1 is equal to sum of the main data element. Minus 5 plus 6. It's equal to 1. And s2 is equal to determinant of the matrix. It's a minus 5, 2, minus 9. It's for the 2 cross 2 matrix. For the 3 cross 3 matrix, it's s1, s2, s3 values. I will show you. Now, minus 30 plus 18, it's equal to minus 12. Now substitute lambda square minus lambda minus 12. Multiplication minus 12, addition minus 1. So it's a lambda minus 4 into lambda plus 3 is equal to 0. What will be the lambda value here? And coming to the lambda, lambda is equal to 4 comma minus 3. When lambda is equal to 4. When lambda is equal to 4. When lambda is equal to 4. Ax, that is a minus lambda I into x is equal to 0. Now a minus 5, 2, minus 9, 6. Lambda is equal to 4, 1, 0, 0, 1. 1, 0, 0, 1 into x1, x2, it's equal to 0. Equal to 0. Now minus 9, minus 4, so minus 9 x1 plus 2 x2 is equal to 0. Next one, minus 9 x1 plus 2 x2 is equal to 0. We won't get, if you take from this equation, if you take first equation, 9 x1 is equal to 2 x2. If you choose any one of the value for the, if you choose x1 or x2 is equal to 1, we are getting the fractional value. Or if you choose x2 is equal to 9, x2 is equal to 9, what will be the x1? We are getting minus. For example, when x2 is equal to 9 means x1 is equal to, we are getting plus 2. Plus 2, that is 2 and 1. We are getting the value, yes, x1 is equal to 2 and 9. But 2 and 9 is not there. Minus 2 and 9 only available in the option B. So it's not possible. Next, when lambda is equal to minus 3. When lambda is equal to minus 3. Same. Minus 5, 2, minus 9, 6, minus 3, 1, 0, 0, 1 into x1, x2. x1, x2, it's equal to 0. It's equal to 0. Is it okay now? Yes or no? Okay, fine. Next one, minus 5, minus 3. Minus 2x1 plus 2x2, it's equal to 0. Minus 9x1, and it's a plus, minus of minus, minus 3, minus of minus, it's a plus, right? So plus 9x2 is equal to 0. From this equation, x1 is equal to x2. That means 1 is equal to 1. So if you substitute x1 is equal to 1, x2 also 1. So it's option D. Option D is the right solution for this question. Guys, is it clear? Up to this point, I hope all the problems are clear. Now we are moving into the next set of questions. Yes or no? Okay, next. Consider a 3 cross 3 real symmetric matrix S such that two of its eigenvalues are A is equal to not equal to 0, B not equal to 0. That means eigenvalues are not equal to 0 with the respective eigenvectors they are giving. Whenever A not equal to B means, so both not identical. It's a distinct eigenvalues. A and B distinct eigenvalues. For the distinct eigenvalues with the real symmetric matrix, x1 transpose into x2 is equal to 0. Right? So here now substitute x1 transpose. x1 is equal to x1, x2, x3 the transpose into y1, y2, y3. It's equal to 0. Now x1, x2, x3 into y1, y2, y3 is equal to 0. Now single row, single column, so single element, row into column. Therefore x1, y1 plus x2, y2 plus x3, y3 it's equal to 0. x3 y3 it's equal to 0. Yes or no? x3 y3 it's equal to 0. Is it clear? Yes, it's option D. Okay, next one. At least one eigenvalue of a singular matrix. One of the eigenvalues of the singular matrix. What will be the solution? One of the eigenvalues of the singular matrix? What will be the one of the eigenvalues of the singular matrix? Singular matrix means determinant is equal to 0. For the singular matrix, determinant for singular matrix determinant is equal to 0. Okay, and product of the eigenvalues is equal to determinant of the matrix. Product of the eigenvalues is equal to the determinant of the matrix, right? So here look at this. Here lambda 1 into lambda 2 is equal to determinant. It is equal to 0 means at least one of the eigenvalue must be equal to 0, right? So one of the eigenvalues for the singular matrix must be equal to 0. Yes, because absolutely right. Next, lowest eigenvalue of the given 2 cross 2 matrices. What will be the lowest eigenvalue? It's a GATE Mechanical Engineering 2005 question. Mechanical Engineering 2005 set 3. I will show you what will be the lowest eigenvalue for this matrix. Lambda square minus s1 lambda plus s2 is equal to 0. We are using the characteristic equation to identify the solution. S1 it's equal to sum of the main and element. It's a 4 plus 3 is equal to 7. S2 is equal to, it's a determinant of the matrix. It's 4, 2, 1, 3. And what will be the value? It's a 12 minus 2, it's equal to 10. Now substitute, it's a lambda square minus 7 lambda plus 10 is equal to 0. Product of the two numbers must be equal to 10, while adding the same two numbers it must be equal to minus 7. So what will be these two numbers here? And it's a lambda minus 2 and lambda minus 5. So considering these two, lambda minus 2 and lambda minus 5, so we are getting the two eigenvalues at 2 and 5, right? Which lambda is equal to 2 and 5. So the lowest eigenvalue in the given matrix, we have identified there are two eigenvalues are 2 and 5. So the lowest value it's equal to 2. Lowest value it's equal to 2. Is it okay? Is it clear? Okay, next. Condition for which eigenvalues of the matrix are positive. Eigenvalues of the matrix are positive means, yes, what will be the condition here? K greater than 1 divided by 2 or K greater than minus 2, K greater than 0 or K less than minus 1 divided by 2. It's a Mechanical Engineering 2016 question. So what will be the condition here need to be satisfied for the given matrix? Here all eigenvalues are positive. Positive means positive integers, no negative values here. Then what it means? condition for which the eigenvalues of matrix are positive, what will be the condition? Okay, yeah, yes, you try this problem and give your solution in the chat box. I am giving eigenvalues are positive. Eigenvalues of positive. Both eigenvalues are positive means it's greater than 0. Lambda 2 also greater than 0. And product must be, what will be the product? Then lambda 1 into lambda 2 must be greater than 0. Yes or no? If the two eigenvalues are positive, then the product must be greater than 0. So we all are aware of it. Lambda 1 into lambda 2 must be equal to the determinant of matrix, determinant of A. Therefore we can consider this here determinant of A, it must be greater than 0, right? So here 2 1 1k, it must be greater than 0. Therefore 2k minus 1 greater than 0, 2k greater than 1, k greater than 1 divided by 2. K belongs to the gate. Yes, it's option A, not D. Okay, because got it? Okay, next one. So before moving to the next question, and after yes, discussing the Unacademy upcoming compact, again I will give you the remaining previous question. First we will discuss the upcoming compact details, guys. You can watch my special classes, India's top educator special classes in Unacademy platform. Download the Unacademy learning app in the Play Store and search my name Sathyamoorthy V in the search box and follow my profile. There you can get my complete course on engineering mathematics for the GATE 2023 or for the 2024. Okay, yes or no? Next, GATE and ESE compact scholarship test to ace your preparations, 20 questions, 60 minutes time. It will be conducted day after tomorrow, coming Sunday, 14th August, 11 a.m. to 12 p.m. Rank 1, you will get 90% scholarship. Rank 2 to 5, 70% scholarship. Rank 6 to 10, 50% scholarship. Rank 11 to 50, 30% scholarship. Rank 51 to 150, 25% scholarship on your total subscription. Okay. Next, accelerate, save up to 44% on your GATE and ESE mechanical and chemical subscription with free extension of up to the 6 months, valid today midnight. Up to the today midnight it will be valid. And in the plus and iconic, in the plus, if you take 24 months, additionally 6 months subscription you can get. For the 18 months, you will get additional 4 months. Here 54,000 it cost. So after the discount and everything, what you are paying? Only 49,740 something you are paying, right? For the 12-month subscription, after all the discounts, you are getting 38,000. 38. If you take the 9-month subscription, additionally you will get 2 months. Additionally, you will get 2 months. So here 33,000. What you are paying? 33,000 you are paying, right? For the 6 months, it cost around 30,473. And if you want to take in iconic also, if you take the 12-month subscription, that's just 47,000. You can get Unacademy GATE and ESE Dreams Mechanical and Chemical Engineering. Get started with the no cost EMI, and and 0% interest on the loan, completely 0% interest. The approval within a 2 hours, minimal paperwork and flexible tenses are there. Apply the terms and conditions as per the rules. So you can get the details by calling this number. Next, less than 6 months to go for GATE 2023. Prepare with us and get closer to the securing your dream job at a PSU. BAR, CAL, ONGC, DRDO, NHI, HPCL, IOCL, CRIS, PGCAL, then GALE. So for this and more jobs available. You can get all the benefits by cracking the GATE 2023. Attention Unacademy GATE and ESE mechanical and chemical aspirants, get the iconic subscription at just an additional $368 per month. Get access to live classes by the top educators, 8,000 plus printed notes and digital notes per branch, 1:1 live mentorship program, ask a doubt feature available, unlimited access to the recorded content. Use the referral code for the 10% offer, Moorthy 536. Yes, use the referral code Moorthy 536 for the 10% offer. So completely you can avail 10% offer through this. Yes, Vision batch for the GATE and ESE 2024 aspirants, August 12th. Today we are starting the new course, new batch with the general aptitude by the Saurav Thakur at 4 p.m. Use the code Moorthy 536. Use the code Moorthy 536 to avail the benefits. Praveen Kulkarni sir, Devendra Singh Negi, and SK Mandal, Marit Tiwari, J.S. Gill, Rajiv Singh, Gaurav Babu, and Vehanandan Sathyamoorthy, Saurav Pandey, Uma Maheshwar Rao, then Saurav Thakur, Aman Raj, Shreyas. So these are the members. They are going to handle the classes for you for the next 2 years, right? Okay, now we are moving to the remaining questions. Next, the number of linearly independent eigenvectors of the matrix. How many linearly dependent eigenvalues are there? 2 linearly dependent and 2 linearly independent values are there. So totally it's 2. Next one. Product of the eigenvalues of the matrix. What will be the product of the eigenvalues of the matrix? So what kind of things we can utilize here? Product of the eigenvalues of the matrix P is, I will show you, P is equal to 2, 0, 1, 4, minus 3, 3, 0, 2, 1. Product means there are 3 eigenvalues, lambda 1 into lambda 2 into lambda 3. It's equal to determinant of P. Therefore, it's equal to 2 into 3 minus 6 minus 0 plus 1 into 8 minus 0. What will be the value? Minus 6 plus 8. It's equal to 2 plus 2. Is it okay now? It's not 6 determinant we need to take. So it's a 2 into 3 minus 6 is equal to minus 3 into 2. It's a minus 6. Second 0 plus 1. It's equal to 2. Option B. Next one. 2000. Next question. 2017. Determinant of the 2 cross 2 matrix is 50. If one eigenvalue of the matrix is 10, the other eigenvalue, here they have mentioned determinant of the matrix it's equal to 50. Then 1 of the eigenvalue is equal to 10. What about the other eigenvalue? We are aware of it. Product of the eigenvalues is equal to determinant of the matrix. It's a property in the eigenvalues and eigenvector. Therefore, lambda 2 is equal to determinant divided by lambda 1. It's a 50 divided by 10. It's equal to 5. 5 is the right solution for this question. Guys, is it okay now? Yes or no? Consider the matrix P. It's equal to 1 1 0 0 1 1 0 0 1. The number of distinct eigenvalues. It's a triangular matrix. It's an upper triangular matrix. It is the upper triangular matrix. So coming to the upper triangular matrix, I will show you. Listen. In the part of upper triangular matrix, eigenvalues are main diagonal elements. So all are 1 1 1 1. How many distinct eigenvalues are there? Only one distinct eigenvalue, right? Only one distinct eigenvalue available in this part. Next, if the matrix in a given matrix A into X is equal to R, and what will be the value of one of the eigenvalues of matrix A? We are aware of it. The formula based. It's completely formula based. Here Ax is equal to lambda x. It's equal to, they have mentioned it's equal to R. Therefore it's equal to R. Right? So what will be the Ax is equal to, so we need to consider the value. Ax is equal to lambda x. So Rn, we can equate the Rn lambda x. And here R is equal to lambda x. R is equal to 32, 16, 64. It's equal to lambda into x 2, 1, 4. And what value multiplication it makes? RHS equal to LHS. Therefore, lambda is equal to 16. You substitute 16. 16 into 2, 32. 16 into 1, 16. 16 into 4, 64. Therefore, option D is the right solution for this question. Is it okay now? Is it clear? Guys, if you want to learn the complete engineering mathematics for the GATE, then you can get complete course with previous year questions discussed in the Plus platform. I am handling the complete course on engineering mathematics for the GATE aspirants in the Unacademy Plus platform. So you can get complete course with the detailed tips and tricks. Next, here, so it's common for all department eigenvalues. So here we are going to practice few computer science engineering questions also. Eigenvalues of the matrix dash. What are the eigenvalues here? It's a triangular matrix. So some of the main diagonal elements are directly eigenvalues. 1, 2, minus 2, minus 1. So these are all the eigenvalues. Next, what are the eigenvalues of the following 2 cross 2 matrix? What are the eigenvalues of the following 2 cross 2 matrix? Identify the following 2 cross 2 matrix here. What will be the value? Guys, are you there? Yes, 2 properties we can use. Property number 1, sum of the eigenvalues is equal to sum of the main diagonal element, that is A11 plus A22. 2, product of the eigenvalue lambda 1 into lambda 2, it's equal to determinant of matrix. It's determinant of matrix. Now, sum of the eigenvalues 2 plus 5 is equal to 7. Yes, 7 is satisfied in option B, S plus C, not in the A and D. Now, there are two options satisfied the first property. Then what we need to do? We need to look into the second property. Product of the eigenvalues is equal to determinant. Determinant is equal to 2 minus 1 minus 4, 5. It's equal to 10 minus 4, it's 6. So the product of the eigenvalues satisfied 1 into 6 is equal to 6. 2 into 5 is equal to 10. So here option B satisfies both the properties. Okay, in case while checking the first property, only one option satisfies, then directly we can select the solution. In case more than one option satisfies the first property, then we need to look into the second property, right? Or directly we can use the lambda square, or another method, lambda square minus s1 lambda plus s2 is equal to 0. S1, sum of the main diagonal elements, is equal to 7 lambda. Product is equal to, it's a plus 6 is equal to 0. 4 matrices are there. So we need to check all the matrices. We need to check all the matrices here, right? How to check? First one, it's like an triangular matrix, right? It's like an triangular matrix. So coming to the triangular matrix, first matrix, in the first matrix, it's an 1, 2, 3, 4. In the first matrix, lambda 1 is equal to 1, lambda 2 is equal to 0. So here one of the eigenvalue we are getting. Next, second matrix, here also lambda is equal to, lambda 1 is equal to 0, lambda 2 is equal to 0. It's like a triangular matrix. So we can take the main diagonal element. Again third one. So we need to select third one. And lambda square minus s1 lambda plus s2 format, lambda square minus s1 minus 2 lambda, 1 minus 1, 0. Yes or no? So 1 plus 1 plus 1 plus 2 is equal to 0. So lambda is equal to minus b plus or minus 2 plus 2 plus or minus root of b square, 4 minus 4ac minus 8 divided by 2. It's equal to 2 plus or minus root of minus 4 is equal to, it's a 2i divided by 2. Therefore 1 plus or minus I. So lambda is equal to, what we are getting, lambda 1 is equal to 1 plus I. Lambda 2 is equal to 1 minus I. It's a third one. Next fourth one. How to calculate fourth one? Fourth one, again it's an triangle matrix, lower triangle matrix. Therefore lambda 1 is equal to minus 1, lambda 2 is equal to minus 1. In how many matrices? It's a minus. Actually it's a minus 1. And only one matrix. In the first matrix we are having the eigenvalues is equal to 1. So only one matrix contains eigenvalue, it's equal to 1. I hope it's clear for all, right? Next one. I will show you the things one by one, then you will get some idea. Consider the following matrix. A, it's equal to 2, 3, xy. The eigenvalues of A are, they have mentioned, it's 4 and 8. That is lambda 1 is equal to 4, lambda 2 is equal to 8. Lambda 2 is equal to 8. And what about the x and y value? The first property, lambda 1 plus lambda 2, sum of the eigenvalues is equal to sum of the main diagonal element, that is 2 plus y. Now 4 plus 8, it's equal to 2 plus y. Y is equal to 10. Y is equal to 10. And if you know the y is equal to 10, it satisfies in the both option A as well as option D. And what will be the value of x? Next, what we need to check here, value of x. So we know the y value. Now substitute that y value into the equation. Therefore a is equal to 2, 3 x 10. Now the determinant is equal to lambda 1 into lambda 2. Lambda 1 into lambda 2 is equal to determinant of a. Therefore 4 into 8 is equal to 2, 3 x 10. It's equal to 20 minus 3x, it's equal to 32. Now 3x is equal to minus 12. X is equal to minus 4. Therefore x minus 4, y 10. And this will be the right answer for this question. Is it okay? Yes or no? I hope it's clear, right? And yes, one more question. Consider the matrix as given below 1, 2, 3, 0, 4, 7, 0, 0, 3. Which one of the following options provides the correct values of eigenvalues of the matrix? Correct values of eigenvalues of the matrix. 1, 4, 3. Yes, it's a upper triangular matrix. For the triangular matrix, directly main diagonal elements are the eigenvalues. Next, let A be the 2 cross 2 matrix with elements A11 is equal to A12 and it's equal to A21. So here there are 4 elements in the given matrix. We can check. That is A11, A12, A21, A22. It's equal to 1, 1, 1, minus 1. What will be the eigenvalues of the A? Lambda square minus S1 lambda plus S2 0, lambda square minus 0 lambda minus 2 is equal to 0. S1 is equal to 0 and this will be the answer, right? Therefore lambda is equal to plus or minus root 2. That is lambda 1 is equal to plus root 2. Lambda 2 is equal to minus root 2. What will be the a power 19? A power 19 eigenvalues are lambda 1 power 19, lambda 2 power 19. That means root 2 power 19 and minus root 2 power 19. So we can write root 2 power 18 into root 2 and minus root 2 power 18 then minus root 2. Root 2 power 18 is equal to, that is root 2 power 2, it's 2. 2 power 9 is equal to 512. So 512 into root 2 and minus 512 into root 2. Therefore it's option D. It's a computer science engineering 2012 question. It's a basic question, computer science engineering 2012. Okay, we are moving to the next question now. Consider the following 2 cross 2 matrix A where 2 elements are unknown or marked by A and B. Unknown elements are marked by A and B. Right? Eigenvalues of the matrix are minus 1 and 7. Lambda 1 is equal to minus 1. Lambda 2 is equal to 7. So what are the values of A and B? What are the values of A and B? So this is what we need to check. Okay. Excuse me. What are the values of A and B? Now sum of the eigenvalues, lambda 1 plus lambda 2 is equal to 1 plus A. Minus 1 plus 7 is equal to 1 plus A. Now what will be the value of A? A is equal to 5. A is equal to 5 available in only one option. So directly we can select the option D. It's not necessary to find the B. If you find the B, we will get 3. Next, the larger eigenvalues of the matrix. So what will be the larger eigenvalue for this matrix? Larger one. We need to identify the eigenvalues first, then we can take the larger. The same lambda square minus s1 lambda plus s2 is equal to 0. Now lambda square, sum of the main element 5 lambda and 4 minus 10, it's a minus 6 is equal to 0. And lambda minus 6 to lambda plus 1 is equal to 0. For lambda is equal to minus 1 comma 6. In that larger value, 6 is the larger value. 6 is the larger one in this question. Next, eigenvalue. The given matrix 1, minus 1, 2, 1, 0, 1, 0, 1, 2, 1. 1 of the eigenvalue is equal to 1. That is lambda is equal to 1. The corresponding eigenvector. So how to identify the eigenvector for this matrix? It's a simple. A minus lambda I into x, it's equal to 0. It's equal to 0. A minus lambda I into x is equal to 0. Okay. I will show you the things one by one. A, it's 1, minus 1, 2, 0, 1, 0. 1, 2, 1 into minus lambda is equal to 1. 1 into 1, 0, 0, 0, 1, 0, 0, 0, 1 into x1, x2, x3. x1, x2, x3, it's equal to 0. It's equal to 0. Right? Now, subtract it. Then what we are getting? While subtracting it, it's 0, minus 1, 2. 0, 0, 0. 1, 2, 0. 1, 2, 0 into x1, x2, x3. There are three equations we are getting. That is minus x2 plus 2x3 is equal to 0. x1 plus 2x2 is equal to 0. Now use the rule of cross multiplication here in order to identify the solution. What kind of equation we are using? Here x1, x2, x3. We need to start with minus. Minus 1, 2, x3, 2, 0, x1, 0, 1, again minus 1, 2. Now x1, if you consider the value, minus 1, 2, 2, 0, x2 divided by 2, 0, 0, 1, x3. x3 divided by 0, minus 1, 1, 2. Now what will be the value? x1 divided by minus 4, x2 divided by 2, x3 divided by 1, that is minus 4, 2, 1. So minus 4, 2, 1 available in the options, so it's option B. Minus 4, 2, 1 is the right solution for this question. Okay. Now one more simple question. Two eigenvalues of the matrix 3 cross 3, real matrix PR. Here they are giving one value. Lambda 1 is equal to, that is 2 plus root of minus 1 is equal to, root of minus 1 is equal to I. 2 plus I, 1 of the eigenvalue, lambda 2 is equal to 3. And definitely lambda 3, 1 is equal to 2 plus means, and another one 2 minus I. Therefore lambda 1 into lambda 2 into lambda 3 is equal to determinant of P, it's equal to 2 plus I into 2 minus I into 3. It's an 2 square minus I square into 3. 2 square is equal to 4, I square is equal to plus 1 into 3. So 5 into 3 is equal to 15. 15 is the right solution for this question. Okay. I hope it's clear for all the students, right? So please stay tuned in the platform, and in the next video we are going to discuss the remaining chapters previous year questions for the mechanical engineering. Okay, until bye from Sathyamoorthy. Thank you all of you.